Hi everybody, this is Mr. Scott and this is your tutorial on how to add up vectors by drawing. So this is going to cover everything that we've done in class, the tip-to-tail method, the parallelogram method, and the component method, and then hopefully by the end of this you'll be able to see every situation and then be able to act accordingly when you see it on a quiz or a test. Okay, so when adding tip-to-tail, it really is that simple. All you're going to do is take the tip of one arrow and make sure that it touches the tail of the other. After that, you can then draw the resultant, which is always going to go from start to finish. Well, we point to where we finish, so in this case, it should be up here. Give me a sec to correct for it. And then, of course, we can also label it with an R as our resultant. It's also important to note that you could have done this the other way. You could have easily put the first arrow as the second arrow, and the second arrow as the first arrow, and you'll still end up with the same resultants. So no matter which way you do it or what order you do it, you're always going to end up with the same start to finish when you add up the vectors, as long as you don't change the direction or change the angle of vectors, which is a common mistake kids make. The next method we taught you was the parallelogram method, and an easy way to think about the parallelogram method is it is just tip to tail twice. So you're going to try and create a parallelogram with two sets of parallel sides, and you're just going to put them together tip to tail, but we taught it to you so that way it would start to introduce you to the idea of components, which is of course the next method. Okay, so let's add them up. Now we're going to take both of the arrows and put the two ends together. We're going to translate and create a clone of each arrow, so that way we complete our parallelogram. Make sure you don't flip the direction in which the arrows are pointing. Make sure they're the exact same length as the two original arrows, and now you're set to draw your resultants. So when you make the resultants, give me a sec here just to get it the right size and direction. You want it to always point to where you finish. So the arrows will always point to the finish, and the two ends are where we started. And of course, now that you've drawn it, always make sure that you label that thing with an R so you get full points and don't miss out on that point on the quiz. But like I said before, remember this is really just tip to tail twice. So if you think about it, you could take away half of the parallelogram, and we just added up two vectors as tip to tail and drawn the resultant. And you could do the exact same thing on the other side and take away the top two vectors, and you'd still have tip to tail on the bottom. But really, that's all the parallelogram is going and putting a bisecting line through tip to tail twice. Lastly, the component method. So when we break down vectors into components, what we're trying to do is figure out how much of the vector goes horizontal and how much of the vector goes vertical. When we figure out how much of each vector goes in those directions, then we can add up just the horizontal and vertical components to figure out what the resultant would be. The most important thing you can do in the component method is draw your dash box correctly. So by doing this box around the vector, we're trying to show exactly how high up the vector goes and also how far sideways it goes. This is going to allow us to draw the arrows much easier. In order to save time, I've already drawn the components here. You can see that the vector on the top left is going up and to the left, so you better make sure your components are being pointed up and also left. And then the vector on the right is being down and to the left in orientation, so you better make sure your vectors go down and also to the left. Okay, now it's time to add up the component vectors. So we have four vectors here that represent the up and down and side to side of two vectors, and we can add those together to try and make a resultant. So I'm going to take all four of these components, which, aren't exactly perfectly horizontal or vertical due to the software limitations, and then put them tip to tail so we can now try and draw a resultant. And as you expect, when you add two vectors, one going up and to the left and the other going down and to the left, you get a resultant that goes almost straight left because the up and down have canceled out in direction, and both of the vectors going left have added up. And just to double check this, we can take the original two vectors and use an old method that we already knew, like the tip to tail method, and still see that, yeah, it's the same resultant that we would have got with the tip to tail method or the parallelogram method. We just used the component method to break it down into how much is going horizontal and vertical instead. And as you probably guessed, we can also take the original two components then and add them up into the vector they would create. So let's do that very quickly in two examples. The first thing we have to do, of course, is draw our box. Now that we got the box, let's draw the resultant of each one of these combinations. So the vector on the left is going to go up and to the right, so my resultant should be up and to the right. And the box helps me draw the vector, so that way I know exactly how far up and exactly how far to the right to make it. And then the vector on the right is going down and to the left, so let's draw that vector resultant also. And now we can just add these vectors up and see what their resultant would make, or we can just leave them as so. It depends what we're being asked for on the quiz or test. The last type of question you might see from us is something like this, where we say add up all four of these vectors. And believe it or not, you could actually use all three methods, each one being a little bit more difficult to do in more steps than the other. So depending on how much pain you want to inflict upon yourself, you can do any of the three, but there's one method that is much easier to use than the others. So I'll pause for a second like Dora the Explorer and let you fill in the blank. If you wrote tip to tail, you win. So once again, when adding these four vectors tip to tail, any order that you pick is fine as long as you make sure the tip of every single vector is touching the tail of the next vector. We add a quick resultant to this combination of four vectors, and note that we still point to where the arrows finish and draw it with an R to label the resultant, and we are done with the tutorial. Hopefully you're all set now to be able to go out there and crush these quiz and tests and draw your vector diagrams.